Inequalities are great to learn about right after you have learned how to solve equations and two-step equations, because inequalities and equations are so similar. There are a few key differences with inequalities. Let's look at the definition of an inequality. An inequality states that two values are not equal. For instance, here we have m is greater than 3. So m and 3 are not equal to each other as in the equations that we've been working, but one side, the side with the variable, is bigger or greater than the right side in this case. All right, little note here, you solve inequalities in much the same way you solve equations. You use inverse operations to get your variable alone. So let's look at some of the symbols that you need to know when working with inequalities. These symbols help you to graph an inequality. Graphing an inequality is the second thing that's different from inequalities and equations. First is the inequality symbol right here. There's a greater than symbol, less than symbol, greater than or equal to symbol, and the less than or equal to symbol. The second thing that's different is that you graph inequalities. You actually draw out a number line and you put a circle above the number that you're graphing. So an open circle means greater than or less than. A closed circle means or equal to. So you use closed circles when the symbol has an or equal to sign underneath the inequality symbol. On the number line, you'll always point to the right, to the greater than side, when your variable is greater than. You will always point to the left or to the less than sign when your variable is less than. Solving inequalities using addition and subtraction. The inequality remains true when you're adding and subtracting. So nothing changes in an inequality when you add and subtract. You just do it just like you did when you were working with equations, except this time you have an inequality symbol instead of an equal sign. So let's start with this example. We have x minus 5 is less than negative 3. So I'm going to switch, just so I can see that plus a negative is the same as subtracting 5. In both cases, I'm just going to add 5 to cancel out this 5. So I add 5 and those cancel, and I add 5 here, and I get negative 3 plus 5 is 2. So x is less than 2. So x can be any value that is less than 2. So when you graph x is less than 2, you draw a number line, put 2 in the middle of your number line, right? Maybe two numbers that are greater than 2, so 3 and 4 to the right, and then two numbers that are less than 2 to the left, so 1 and 0. Since x is less than 2, I'm just going to draw a open circle, because remember, if it does not have the or equal to sign on it, the circle should be open and clean on the inside, not colored in. And since x is less, I'm going to point to all the numbers that are less than 2. So my arrow is going to point to the left. Let's try this example. Negative 3.5 is less than or equal to 4 8/10 plus m. So I'm going to start on the side with king variable, which is the right side of the inequality symbol, and I'm going to subtract 4 8/10. Minus 4 8/10 minus 4 8/10. It's going to give me a negative 8 3/10 is less than or equal to m. Now, I'm going to graph this. I'm going to draw my number line. I'm going to put negative 8 3/10 on the number line. And to the right, I'm going to draw numbers that are greater than negative 8 3/10. And to the left, numbers that are less. And then I am going to graph negative 8 3/10, because this is my value of the variable. I'm going to graph negative 8 3/10 with a closed circle because the inequality symbol says or equal to. It has a line underneath it, so I color in the circle. Now, you need to pay close attention because this is probably one of the #1 mistakes students make when working with inequalities. Right here in this example, this arrow points in the same direction as the inequality symbol because x is less, and I'm always graphing the variable. In this example, m is greater than or equal to. So since m is greater, and again, I'm always graphing the variable, m is a greater number, greater than negative 8.3. So I'm going to point to greater numbers, which are to the right. The numbers that are greater than are always going to point right. Well, my inequality symbol, though, is pointing this way, but my graph is pointing to the right. So your graph will not always point in the same direction as the inequality symbol. You always have to look to see, is my variable bigger or greater than, or is it less than? That is what determines which way your arrow points. In this case, it's greater than. In this case, the variable was less than. So you can check your answers when you are solving an inequality. We got the answer x is less than 2 for this inequality. So what I'm going to do is I'm going to take a number that's less than 2 that I graphed on my number line, the number 1, 0, -1, -2, -3, so on. And I'm going to plug it in for x and see if my inequality is true. So let's pick a number that's less than 2. Let's just do -2. And I'm going to plug it in for x. So -2 minus 5 is less than -3. -2, I can switch that if that helps me. -2 minus 5 or -2 plus a -5 is a -7. So get -7 is less than -3, and it's true. So this inequality checks out. So let's look at this one. If I choose, for this inequality, we got -8 3/10 is less than or equal to m, and m is greater than or equal to -8 3/10. So we graphed m as greater, and so I'm going to choose a number that's greater than -8 3/10. I'm going to choose an easy number, a positive number. Let's just choose 2. So I'm going to plug 2 in for m in this inequality. So I get 4.8 plus 2, which I know is 6.8, is greater than or equal to -3.5. And 6.8 is definitely greater than -3.5. So it checks out. It works. Solving inequalities using multiplication and division, part 1. One important statement here is that an inequality remains true when multiplying and dividing by positive numbers. You need to keep in mind when you multiply and divide by positive numbers, you don't have to worry about anything changing. Everything stays the same. So I have x divided by 10 is less than or equal to -2. So I'm going to use inverse operations. I'm going to solve this just like I would an equation, except I have an inequality sign. That's the only difference. And the inequality sign, of course, has a different meaning to it. So I have x divided by 10. I'm going to use the inverse of division, which is multiplication, and I'm going to multiply by 10. The 10's cancel out. I'm left with x. I'm going to multiply the right side by 10, and I get -20. So x is less than or equal to -20. Now I'm going to graph it. I'm going to draw out my graph, and I'm going to put -20 right in the middle of my graph. I'm going to put numbers that are greater than to the right and less than to the left. In this example, I'm going to put a closed circle above negative 20 because I have the or equal to symbol, the line, underneath my inequality. And I am going to point my arrow in the direction that means less than, which is to the left, because x, my variable, is less. All right, let's look at this example. 2.5x is greater than 11 and 2500. I'm going to divide by 2.5, divide by 2.5. X is greater than, let me work this out, 2.5 into 11 and 2500. I need to move my decimal over, bring it up. 25 into 112 goes 4 times. 4 times 25 is 100. I get 12, bring down my 5. 25 into 125 goes 5 times. And 5 times 25 is 125, so that's my answer. So I get 4.5. So x is greater than 4.5. I'm going to put 4.5 right in the middle of my graph. Numbers greater than 4.5 to the right. Numbers less than 4.5 to the left. I'm going to draw an open circle because of the symbol. And I'm going to point my arrow in the direction that means greater than, which is to the right, because x is greater than. This inequality, and we said x is everything that is less than or equal to negative 20. So x could be negative 20, it could be negative 21, negative 22, and so on. So I'm just going to pick one of those numbers and plug it in for x. So I'm going to go with negative 22. So negative 22 divided by 10 is less than or equal to negative 2. And negative 22 gives me negative 2.2, negative 2 and 2/10. And negative 2 and 2/10 is definitely less than negative 2, so it checks. This next one, x is greater than 4.5, and so to check it, I'm going to pick a number on my number line that I graphed that is greater than 4.5. Well, 5 is greater than 4.5, so I'm going to go with 5, and I'm going to plug it in for x in my original equation. My original inequality. So I have 2.5 times 5 is greater than 11.25, and 5 times 5 is 25, 5 times 2 is 10, plus 2 is 125, and I have to keep my decimal, so I have 12 and a half. 12 and a half is greater than 11 and 25 hundredths, or 11.25, and it's true. And so that checks out okay.